Electric generators induce an EMF by rotating a conducting coil in a magnetic field, thereby converting mechanical energy into electrical energy. Essentially, a generator consists of two magnets set up to produce an external magnetic field that begins at the north pole of one magnet and points toward the south pole of the second magnet. A coil of wire is placed in a magnetic field between the two magnets. The coil of wire is attached to some type of rotation crankshaft that serves to rotate the coil of wire inside the magnetic field. And anytime we have a moving conducting wire inside of a magnetic field, a motional EMF is induced. Since the coil of wire is rotating, the induced EMF will produce an alternating current within the wire. We can use Faraday's law to show that the current is alternating within the coil. So remember that the EMF produced is equal to the negative change in magnetic flux over time. If we assume a uniform magnetic field, we find that the EMF is equal to the negative strength of the magnetic field times the area of the loop times the cosine of the angle of the magnetic field with respect to the area vector, all over a change in time. Now our loop is rotating, so remember back to angular velocity. Omega is the change in angular displacement over time. We actually want to find the time dependence to the EMF, and if we assume that the coil is rotating at a constant angular velocity, we can rearrange to solve for the change in theta. A little bit of calculus allows us to take the integral of both sides of this rearranged equation. And we get an equation of omega t plus theta naught equal to theta. We can easily choose theta naught to be 0, which leaves us with theta equal to omega t. Of course, we can now replace theta in our EMF equation with omega times t. Since n, b, and a are constant, we can pull them out of the derivative, and we can replace our theta in our EMF equation with omega times t. So we see that our induced EMF is equal to the negative nba times the delta cosine omega t over delta t. Taking the derivative of this function, we will get a negative sign of omega t times omega. The negative signs cancel, and we find that the induced EMF for a rotating coil of wire is the number of loops times the strength of the magnetic field times the area of the loop times the angular velocity times the sine of the angular velocity times the time. Basically what this says is the induced EMF varies sinusoidally with respect to time. This means that the current produced inside the conducting wire is alternating back and forth. And one more thing. The quantity of Nb omega is what is known as the peak voltage. This is simply the highest voltage that can be attained by any particular generator, and you will see it substituted into our EMF equation.